Hi, in this video we're going to talk about equations. And in this course we're going to solve equations algebraically. And the main reason that we're going to follow the steps of algebra to solve equations is to prepare you to do equations both in this class with whole numbers, fractions, and decimals, and also to prepare you for success in Math 20 and other future math classes. So when we're solving equations, we're going to first ask what has been done to the variable. And variables are letters of the alphabet that represent numbers in a specific problem. Then we're going to perform opposite operations on both sides of the equation. So the opposite of addition is subtraction, the opposite of multiplication is division, and we need to be sure that we show our work on both sides of the equation. The reason that we do this is because all equations have an equal sign, which means that we need to maintain balance on both sides of the equal sign. And what we're trying to do is isolate the variable to solve for the variable. So what we want to end up with is a mathematical sentence that looks something like this. X equals some number. We want to find out what is that number, or if the variable is a different letter. Z equals some number. We're trying to find out what that variable represents in the problem. So let's take a look at this first problem here. X plus 97 equals 582. So we're going to look over here on the left side, on the side of the equation with the variable. And we'll ask, well, what has been done to X? What's with it? Well, it has plus 97 with it. So 97 has been added to X. So what we need to do then is the opposite of addition. And the opposite of addition is subtraction. So we're going to show that we're subtracting 97, and we have to show that we're subtracting 97 on both sides of the equation. Our next step is to work this problem vertically. So we're going to take a look at the left side. X, well, we haven't done anything to X, so we'll just bring it down. 97 minus 97 is 0, so that essentially cancels out. Then we bring down our equal sign, and then over here on the right we need to do our subtraction problem. So we have to borrow, because we can't do 2 minus 7. 12 minus 7 is 5. Again, we need to borrow. 17 minus 9 is 8, and 4 minus nothing is 4. So we find that X equals 485. We can always test our answer to see if we are correct, and we can substitute 485 for the X in the original equation. So if we say 485 plus 97 equals 582. Well, is that a true statement? Yes, it is. So we were correct. Let's take a look at this next example. Here we'll ask again, what has been done to the variable? So what has been done to y? In this case, it has been multiplied by 15. So we need to do the opposite of multiplication, which is division. So I'm going to show that we're dividing by 15 on both sides. 15 divided by 15 cancels out. 15 divided by 15 is 1, and 1 times any number is that number. So y times 1 just leaves us with y. So y equals 135 divided by 15. So then we need to do that division problem to figure out what y is. 135 divided by 15, and 15 goes into 135 9 times. 9 times 15 is exactly 135. We subtract, and there's nothing left. So we know then that y equals 9. And again, we can check our answer. If we want to put 9 in for y, we can do 9 times 15 to double check and make sure that we do indeed get 135. So that's how we solve equations. We need to be sure that we do opposite operations and we show our work on both sides of the equation